Hello, I'm John Chivacco, the co-chair of the NY-GEO 2023 conference and a board member of the New York Geothermal Energy Organization. I'd like to welcome you to this recording of a live presentation from the conference, a two-day event which was held in Albany, New York on April 26th and 27th of 2023. This year's educational sessions and keynotes represent the latest in ground source heat pump system design, product innovations, and installation practices, along with important policy, regulatory, financing, and incentive updates. This presentation is one of over 40 sessions from the two-day event, all of which were recorded and available at NY-GEO's website, www.ny-geo.org, along with session descriptions and a link to download the slides from each of the sessions presented. NY-GEO is proud to make this content available to our members and other industry stakeholders, and if you are a member, thanks so much for your support and participation. If you find this content valuable and for some odd reason you are not yet a member, consider joining NY-GEO at the appropriate membership level with details available at our website. The live recording from the NY-GEO 2023 conference will start in just a moment. Thanks so much for listening.
Good morning, early afternoon, whatever it is. My name's Terry Proffer. I'm with Major Geothermal out of Denver, Colorado. And we're going to talk about why we can put in pipe in deeper boreholes. And there is a lot of myths that we hope to dispel. I understand in New York you have a permitting limit of 500 foot without going to a really ugly permitting requirement for deeper, which, as I understand it, has no basis in science or engineering. It's just arbitrary by government. But I think you guys are seeing it, that with more urban locations, the only thing we can do with a vertical ground loop is go deeper to make sure we get enough capacity. So anyways, one of the concerns is related to that is, will the pipe survive at a deeper depth? And yes, it will. That's the short answer. We're going to give you some real world examples and give you a link to a calculator to where you can calculate it yourself and estimate what your maximum depth for the type of pipe you're using. And just to be clear, I appreciate the opening slide that said I was a PE. I'm not. I'm certifiable. I mean a certified geoexchange designer, but I am not a PE. But I've been doing this since 1992. Okay, so I originally did a variation of this presentation in 2014. And it was a result, we had a project that I caught a driller not grouting the holes from bottom to surface. He'd go all week and then grout, and I was worried about bridge off, not to mention that it was against our specification and Kansas state law where this project was located. So anyways, he said, well, the pipes won't survive anyways, even though we had warranty from the pipe manufacturer. Oh yeah, it'll work. Well, this guy really made trouble. He wanted to go to shallower depths, and he said, it'll work just fine. And I said, so you've got the liability insurance to prove that? And anyways, it devolved from there. So the client wanted something other than anecdotal proof, so I started digging around. At the time, I didn't know the right people to ask because there was other materials to prove that plastic pipe, HDPE pipe can survive at deeper depths. But since then, I've updated this presentation, and we've got a lot more due diligence now. So one of the things is Ryan Carta, to give credit where credit is due, with GeoConnections and GeoPro, and he's now with Dandelion. He came up with a great presentation, and I actually talked to him about this, say, hey, I'm pirating some of your information, but I'm giving you credit. And he said, oh, that's okay, that's fine, so good to go. The other thing is the updated version of the ASHRAE design manual now has a reference for pressure ratings and collapse depths for thermoplastic pipe. So we do have a lot more due diligence and technical information to back this up now. So why do we go deeper? Well, urban environments. You don't have any place to go but go down, go further down. Some drillers kind of like it because there's fewer rig setups. You may lessen the amount of excavation for headering, which is always an advantage. And another technical feature, often when you get into denser geology at depth, you have a higher thermal conductivity. But that can be a two-edged sword. You could get into a higher thermal gradient at a deeper depth. And just for you guys that do thermal conductivity tests, that's why you want to send a thermistor down that ground loop and not trust to circulating and trying to interpret undisturbed temperature off an average water flow. So what are the concerns? Well, we get the pipe's going to burst if it's too deep, or buckle. Burst if there's no surrounding pressure. It's going to blow out. On high-rise buildings, you need to put an intermediate heat exchanger between the building and the ground loop. We need to go deeper. We have to go to a thicker wall pipe. Well, that's yes and no. But I've reviewed projects where we've routinely, for the past 30, 40 years as an industry, have been using DR11 at 300-foot holes. But I ran into one peer review project that gentleman wanted DR7 on his 300-foot holes. Had a pretty high pressure drop, as you might imagine. So if the preceding were true, the short answer is our industry would not exist. We would have failed systems right and left. So a few examples, anecdotal information. And then this is from Beatty Geothermal. I think Mr. Beatty is now with Salas O'Brien, and but he's with his firm, and mostly in Toronto. He's got 650-foot deep holes, and this is with PE 3608. We now have 4710. We'll get into that a little bit more. But he routinely did deeper holes in Toronto because that's all he could do. Just didn't have the land. Geosource Energy, Stan Reitsma. I don't know if Stan's here or not. Stan's been a great asset too. He's one of those assets I wished I would have met a long time ago, because he routinely goes deeper because he has to. He's doing like 700 and 800 foot deep holes now. I've been in contact with some geo junkies in the Chicago, Illinois area. They've been doing 600-foot depth loop installations for a long time. Found that the Swedes have been going to 200 meters, and they're using DR17 pipe, and they're not failing. Some of my projects in Colorado routinely going to 500 feet. So we have one in Montana State University that we had no choice. The architect kept producing the area on us. We got to save the trees. Okay, so we go deeper. We went to 700 foot on that. System's working fine. 600, 800, 850, 600, 550 foot. And we're not having problems with these jobs. This is just a photo of a driller. In fact, this was on the project in Kansas where the driller got caught not, yes, sir.
I was going to tell you in New Jersey, 10 years ago, we actually put 2-inch events down 2,000 feet.
And it lasted, didn't it?
It's working well. It's DR11. And at the top, at the very bottom, we switched to a DR9.
Oh, okay, so you used two schedules for the depth of the hole. Okay, cool. Another way to do it. And that's Jeff Erlob. Jeff, his company, Salas O'Brien, they're going to be the world dominating ground source heat pump company. They keep sucking people in. Doing a great job. So, and this was, we're going to talk about 3608 PE plastic briefly, but remember, the industry has progressed now to 4710, so this is even weaker pipe from the time. So one of the things we look at is the hydrostatic pressure on the inside of the pipe. Well, you calculate that by 0.4335 PSI per foot times whatever your depth's going to be. Pretty simple calculation. So this example is in downtown Denver, 81 holes, 450 foot deep, but it's the ground loop is there's a 9-story building on top of it. So all the hydronic piping goes to the top of that building. And we have no intermediate heat exchanger. It's been up and running since 2008. Has not blown out any pipes yet. It's what it looks like from the outside. And by the way, this building it's a retrofit. It was built in the 1960s. So it's low-income housing for Denver Housing Authority. They had 2 problems with the mechanical system. It was dying, and the outside cooling tower, all the neighbors in the neighborhood hated it because it was noisy. The other problem was it's not in a real good neighborhood. So the local, excuse my language, hood rats decide to use the cooling tower for target practice occasionally. So anyways, the city of Denver got tired of fixing it all the time. So we went to 450 foot deep, inch quarter DR11. Like I say, we've got a 9-story building on top of the loop field. So common sense, we have grout around the pipe, we have water in the pipe. So once the pipe is grouted and full of water, how is the pipe going to burst or collapse? It's not. The pressure inside and outside is equalizing out. So that's the common sense part. So using the nominal ASTM ratings for the pipe, let's see, oh, did I jump? This is supposed to be, there it is 160, I'm sorry. Thought I had 4710 up here. So with our downhole pressures from the grout versus the water, we have a differential of 125 pounds. And this is with silica grout. This was before we had graphite, which has a lower density. But even so, at 450 foot from surface, just on the ASTM ratings, with that differential, we should be more than safe for DR11. So we add on the, I'm sorry, we're looking at the building elevation factored in. Now the elevation actually helps us to narrow that delta between the pressures. So we're even more safe with the DR11 if we're going to believe that maximum pressure rating. And by the way, that pressure rating is 1/4 of the unconfined pressure rating of that pipe, so it's very safe to begin with. So now we have a...
If I haven't put water in the pipe yet, then I have full delta on pressure.
Hold that thought, because we're going to get into that. So, but now we have 4710, that's kind of our industry standard for HDPE. So it's even tougher. So accounting for a 600-foot deep hole, the grout using silica grout with a 0.90 thermal conductivity and a 1.0 conductivity thermally enhanced grout, So DR11, we have a nominal safe pressure rating of 200 PSI. So at 600-foot depth, the differential between the water and the grout is very nominal. And your question, I'm glad you asked that. I want everyone to be thinking about that. If we don't have that unconfined pressure, if we drop a loop in with an ungrouted hole, or we load it into just mud, if it was mud rotary, I want you to be thinking about that, because we're going to get into that and why it's important to grout it fast. Yes, sir?
How are these pressure ratings impacted?
Pardon?
How are these pressure ratings impacted?
We're going to get into that. Yes, sir?
Aren't the burst pressures much higher than
Yeah, these are.
No, I just said, aren't there published burst pressures that are much higher than the
Well,
200?
we're going to get into how the ASTM pressures are determined, but these are actual 1/4 the actual burst rating unconfined. So the ASTM values are pretty conservative to begin with. And I had a little help with Dr. Matt Anderson, University of Minnesota. Ran into him. He specializes in these kinds of studies. You know, I guess the guy doesn't have a life. He just talks about pressurizing pipe and what it'll tolerate, what it won't, but you can never have enough friends. Anyways, he helped put up this really cool graph about, based on the published ASTM ratings, we ought to have this kind of safety range for these kind of depths. And he did another one based on the different, and again, this is with densities of thermally enhanced grout using silica. So this is a little dated and vintage, apologize, I haven't been able to update it yet with bentonite graph, but Ryan Card, I wish he was here right now, because Ryan actually put together this for thermally enhanced grout with graphite. So again, with these depths, with the different thermally enhanced grout values, in theory, you know, we should be looking at 700-800 feet on most of these things and still not have a problem. So accounting for a vertical loop with 4710, again with the 0.9 grout or 1.0 grout, with the building elevation factored in for our 9-story building, again, the difference between the water pressure downhole and the grout with a 9-story building, we're even safer. So what this suggests is the density of the grout and the water counteract each other. So there's no place really for pipe to go to fail or anything. And at the time I put this together, I had made the opinion statement that, you know, for 600-foot depth, even 3608, we're going to be safe at. But that's a moot issue now, because I don't know any pipe manufacturer that doesn't do anything but 4710 now. Or the equivalent, what is the Canadian standard, PE 100? I think that's right. But this statement is also to keep in mind, the ASTM pressure ratings are empirical to a certain point. And just a conceptual graphic, you got water inside the pipe, it's trying to push out, but the grout surrounding geology is pushing in. So, and as most of us veterans know, the pipe does not go in and stay perfectly centered. rotary drills, corkscrew, the borehole. Sorry for the bad art. I'm not real good at these, but I try. So even if the pipe's up against the wall, it's still pressing against something that's pressing back in against the water. Common sense, right? Shouldn't be an issue. So our friendly driller that was trying to make grief for not, when I caught him not grouting the holes in Kansas, he said, well, I'm going to prove they're failed. So we cut the pipe on some holes, and we sent a plumb bob. I swear, our last martini was at 10 o'clock last night. I haven't had any today yet. So, and he provided the wire line and the plumb bob. Now the plumb bob was right at 1.25 inch OD. The inside of DR11 pipe with no ovality, that is, it's perfectly round, is 1.358 inches. So we've only got a little over 5/100ths of an inch for that plumb bob to go down the leg of one of these ground loops. Now think of that. We're going down 600 feet. If there's any ovality or obstruction, that plumb bob should not go down it past it. So we tested one ground loop, was grouted full of water. The plumb bob went down both legs without a problem, came back with no problems. We moved to the next one, and the next one, and the next one. And then I said, hey, we got a couple holes you haven't grouted yet. Let's go ahead and put that plumb bob down there, and by the way, let's pressure test it, because theoretically it should blow out. Guess what? It didn't. Worked just fine. So Mr. Driller, who, by the way, this guy, I did not want him on the job. There was like 3 drilling contractors that were experienced in this part of Kansas City for deeper boreholes. You could have spit on all their bids and hit them. All their costs were about the same. Well, this guy came from 3 states away, and he was 50% cheaper. Well, the reason he was 50% cheaper, he wasn't grouting the holes. He wasn't following specs, and he got caught. By the way, how many of you guys design ground loops? How many of you do site visits? Golly, I love to see that. It's, you got to make sure what you're designing is going in the way you expect it to. So one of the reasons that people are concerned is they don't understand how the ASTM standards are determined. And at Plastic Pipe Institute has since updated this, by the way, so this is a little dated, I apologize. But at the time, we really didn't have ASTM information in the handbook for the environment of a vertical ground loop. Very frustrating. So how's it determined? Pressure rating and PSI for the ASTM D2837 value, twice the hydrostatic design stress rating in PSI divided by the DR ratio -1. So for 3608, we can actually go to 800 PSI, and the pipe, that's about where it should burst without any confinement. And for 4710, we should be able to go to 1,000 PSI before we're concerned about bursting it with no confining pressure. So for PE 3608, DR11, that's how we get the 160 PSI rating. But that DR11 pressure rating, it doesn't matter if it's 3/4 inch pipe or 6 inch pipe, it's the same pressure rating. Well, that doesn't make sense, because have you guys seen like a cross section of 6 inch DR11 HDPE? You can run over that pipe with a 1-ton truck, and you might get it to oval a little bit, but that's about it. This stuff is tough. So for 4710, using the same calculation how the 2837 value is determined, we should be more than safe to 200 psi. And I won't go in and read all this, we'll burn too much time. By the way, these presentations will be available from New-York-GEO, is that not right, Matt? Matt. The presentations will be available later, like a PowerPoint on the, okay. So, again, it's the environment that we're concerned about, and that's why the pipe is, pretty robust for what we're doing. But what I reference on these next few slides is where to find the information. So if you want to do the due diligence on me, I welcome it. And again, I'm going to reference some updated information I think will give you even more confidence. So one of the things about buckling that I had to talk to the client in Kansas City about was, I pointed this out from chapter 6 in the PPI handbook. The equation for buckling given in this section is here to provide assistance when designing shallow cover applications. The emphasis is mine. And for pipes placed in casings without grout encasement. Again, a lot of this was for pipelining, unconfined placement of pipe. So it really doesn't apply to a ground loop, or at least in a vertical borehole. And one of the things I found as I read through all of the PPI documentation, which by the way was about as exciting as watching paint dry, so a lot of fun. Most of the stress and test considerations were concerned with point loading, unequal pressure surging, that sort of thing, mostly for process pipelining and oil and gas and water and septic. So at the time, Chapter 13 discussed the use as a ground heat exchanger, but there's nothing talking about what the pipe could survive with at that time. So as the need for deeper installations increase, we need some tools to know how deep we can go. We're looking at the time, 2014, I saw the need, or I thought we would need larger diameter pipe just to offset pressure drop considerations for deeper holes. As I understand, is that VersaFlow in Canada now has a 2-inch U-bend. So, people are starting to respond to the industry for what we need. So now, if you're a member of ICSPA, you can go onto their website and they have a pipe buckling calculator, burst calculator, if you will. And it's very easy to use and it'll give you a little more confidence. And it was developed by PPI. ICSPA kind of made it easier to use than rather than just a spreadsheet. So it's actually an online calculator, free to use if you're a member, and works pretty well. Golly. Let me turn this thing off. So this is from Ryan Carta's later presentation, which actually was a year or two after I made mine, and I didn't even know it. And so this is the Plastic Pipe Institute formula for calculating allowable unconstrained pipe wall buckling pressure. Remember, this is unconstrained for this value. Keep that in mind. So directly from Ryan's comments, let's see, the external pressure rating, or EPR, where it will theoretically collapse, referred to pipe buckling. Well, EPR of a U-bend depends on its temperature, wall thickness, ovality, that is the degree of roundness or deformation, and duration of exposure to external pressures, and that's my emphasis. And that's really important when you think about, you get the loop loaded with water, why you don't want to wait to grout it. Not only is it a bad thing, you might bridge off a borehole, but you want to get that confined pressure around that pipe as soon as you can. And the deeper you go, the more important that becomes. So I ran a couple of the calculations just as an example. So assume DR11 1.25 pipe, pipe ovality of 3%. By the way, on the calculator, it'll have some suggestions like what to select for safety factor, ovality, that kind of thing, if you don't understand all that. And the important part, in my mind, is the duration of sustained loading. That's how long does it take to actually grout the hole after you've got it loaded in the borehole. And in this case, made an assumption, maybe it's in the summer, so we're loading that pipe while it's 95 degrees outside. We also consider Poisson's ratio and density. That's for water, 62.4 pounds per square foot of water. And I've had people say, well, we've got antifreeze. No, you don't put antifreeze in until you got the air purged out of the system. So you should never do that. Why? Propylene glycol, if you're using that for antifreeze, likes to entrain air. So why would you want to fight that when you're purging? Just a tip. And then also, we take into the account the grout density, and there are tables to select from on the online calculator. So in this case, for 1.25 DR11 pipe, we should be able to go to 800 feet safely. So let's make a change. Let's change the ovality to 1% instead of 3%. Still using a safety factor of 1.5, 1 hour for sustained loading. We did drop the temperature from 95 to 85. We should be able to go to 1,000 feet now. Let's make one more change. What's that? I'm sorry. High density polyethylene, dimension ratio 11. What's that? 1.25 inches. But it doesn't, the calculator does not account for that. It just wants to know the dimension ratio. So again, this is real conservative because the 1.5 pipe has a thicker wall thickness than 1.25 inches. So this is something that's not considered in the calculator. But making these assumptions with that calculator, we should be able to go to 1,000 feet.
This assumes the 4703.
4710 HDPE.
No one makes 3608.
Nope, and this is all, by the way, the calculator assumes 4710 because no one makes 3608 that I'm aware of any longer.
But your earlier charts were saying that ASTM has pressure, 150, 200 pounds. So basically said you can't do it. But you're saying because the burst pressure is 4 times higher, we can make it.
It's not just that, it's the environment. That's what this calculator takes into account. Unconfined is the burst pressure, how ASTM develops that. That ASTM rating does not really apply to the environment of a ground loop. That's the point I'm trying to make.
I understand, but if I'm unbalanced or unconfined for, so based on your example, if I've got a 500-foot well,
Right.
how long is it going to take you to fill it with grout?
Well, the key
Or a
part...
1,000-foot well in this case, how long is it
The
gonna
key
take?
part, well, it might take 3 or 4 hours, depending on the equipment, the experience of the crew, all that. But the key is not the entire borehole, but the lower part in particular. And what's that cutoff? I'm not sure. But common sense tells me you want to get that last 200 to 300 foot on a 1,000-foot borehole, you have to grout by standard anyways from bottom up. So that trimming line better be going to total depth. This is another reason when you see a driller that's inexperienced in the industry and he's just pouring grout from the top of the hole, assuming that it's going to the bottom of the hole, you don't want that. They've got to grout from bottom up.
Right.
Not only for protecting the pipe, but what if you have a bridge off and you don't want, you have an unconfined or an area of the borehole that has no grout in it. So that's why the standard is to grout from the bottom up, which works in our favor for protecting the pipe. But I encourage you to work with this. Yes, sir.
Now, what I've been seeing, Jerry, is
Wait.
they load the hole with the U-bend, and then they move on, and then the grout crew comes behind, and then they try to jam their trimmy down
Right.
later. And then you're always wondering, okay, how far is the trimmy really going down that hole, right?
That's why I asked for a marked
Trimmy.
trimming, so I
Right.
can count marks.
But we're not there all the time, right? We stop in, do a site,
Exactly.
visit, and then you look at it, yeah, it looks like they got it down that time, but you kind of wonder through that process. So I always hate delaying the grouting. When they load the U-bend, I would wish they would
No.
send the trimmy with it, and then,
I get you. There's only so much we can do, but here's the other thing. I love general contractors that have an on-site superintendent that's anal. And I get those guys trained to be my eyes and ears. And I've got a lot of drillers that cuss me out and said, that guy's a pain in the ass. He's always following. I said, good. But most drillers, I'm finding, they want to do the right thing, and they're concerned because for our specs, they're having to guarantee their ground loop and pressure integrity. In fact, we require them to fill out so it's in their handwriting that they've done a competent pressure test. And of course, what we're doing to make sure they get the pipe down to total depth, there's 2-foot markings on that pipe, and we look at that just to make sure. You're right, Jeff. We can't all be out there all the time. I wouldn't want to be. Well, some days in the office, I'd rather be with the drillers. That's another story. But the point is that
we have more questions. How far are you? How many more slides do you have?
2 or 3, 4. But the point I'm trying to make with this calculator, you now have a defensible tool to figure out what you think it'll handle. And based on experience, seat of my pants experience, oops, I really wouldn't have a problem putting 1.25" DR11 or DR11 1.5 down a 1,200-foot hole. If that driller is treating that pipe right, it should not be a problem. Now, here's the what if scenarios. So, talking with Stan Rietzma, who's a veteran at deep hole loop installation, he's concerned, what if you got a bunch of scratches? And we're not talking like general handling, but a deep gouge into that pipe. We don't really know if that could harm the integrity of that pipe, but it could, in theory. So again, it's how you handle that pipe. Now, there's not much you can do once the pipe's scraping along the edge of the borehole. So, there's a lot of unknowns still. The other thing is when you start working with that calculator, ovality, or how round that pipe is going in the hole, is really, really important. It will really limit you on a safe depth, or what the formula says it will do. So, I just don't, when I go out with drillers, I share this information, and they're concerned. They don't want a failed system. So they work with their guys to try and stay above board. I mean, my problem now with our industry is really heating up. So we're going to attract new drillers. We need them. We need them. The problem is a lot of them are going to have the experience and not understand these critical considerations. So if you're designing the loop, you want to be out there at least long enough to start getting a feel for making sure people are doing their job right, and train general contractors to help be your eyes and ears. But every time I've shared this information with the driller, they want a copy of it, and they'll sit down with all their employees and said, we're doing a 700-foot deep loop installation. We are going to take care of this pipe. I don't know anyone that wants to intentionally put in a failed system. I have run into some drillers that, thank God, are no longer in business. They didn't care, and we had problems with them, but they kind of filtered themselves out of the industry finally. So, conclusion and options. In my opinion, if it's purpose milled for going in a ground loop, it'll tolerate a lot deeper depth than you think it will, or what the ASTM unconfined pressure ratings say. Good pipe handling is important. And what I think is the most critical, based on the calculations, how long it takes you to grout that hole is very important. So when I catch a driller, I'm going to drill all week and I'll grout the last day. No, you're grouting as soon as you are at total depth and load that pipe. Either the trimming pipe goes down with the U-bend or follows it immediately. And well, that's going to take more time. We'll do it. That was part of the spec. We expect it. And most competent drillers that are responsible say, I understand that we're going to do it the right way. I still think we've got a theoretical formula now, and I'm not very smart for research and all, but I would love to see the Plastic Pipe Institute, various pipe manufacturers, figure out what we can really do with pipe. How deep can we really go and have some due diligence and actual research? Because, you know, we know it'll go deeper. We've got a theoretical calculator for that now. But where the rubber meets the road is some actual testing. That's what I'd like to see. Would that be inexpensive? No. But when you see the growth of our industry, I think the stakeholders should think about, you know, maybe coming up with a really heavy-duty research plan with the intent of going deeper and see how deep we can go before we start failing pipe. That's what I'd like to see. I mean, we'd really like to see what it'll handle. And just some thanks. Initially, I bugged all these poor guys back in 2014, and recently Jeff Hammond, Lance McDevitt with PPI, and then I had a lot of references and later references, and I do cite Ryan Carta's information. He has he's got a plastic pipe, he did a publication with Geo Outlook, the old IXPA publication back in volume 13. I think that was 2016, whatever. And then installation practices, another reference from Ryan Carta. And then finally, the new IXPA, the updated version of the ASHRAE geothermal heat pump design manual. Appreciate it. Hopefully, I didn't misspeak too much.
Good morning. My name is Gino Derezzi from Ground Heat in Toronto, Canada.
Yes, sir.
And in the height of the need for pipe, some of the manufacturers, when they extrude pipe, they will roll the pipe into the roll, still warm.
Yep.
And you're going to have oval pipe.
I am concerned about that.
We know that because when we bring the pipe in the field and we have the fittings and we have the heaters, they don't fit.
Yep.
So now we're doing 850, 900 feet drilling right now. And that's the biggest worry we have, is because as soon as that pipe starts becoming oval, you're going to have that problem with that.
You know, that you make a good point, and I'm not trying to neither throw anyone under the bus or promote another vendor. But when I started learning about this, one of the vendors that's a favorite for the drillers in the Rocky Mountain region is Centennial. And we started looking at their pipe that was delivered. It's pretty round. And I know some of the principals with Centennial in Nebraska, and they said, yeah, we recognize that. That's why we roll them cold. And, you know, so I learned something. Not every vendor rolls their polyethylene loops cold. After they mill it, if it's hot, very much a chance for ovality.
One other item. On your first slides, so I'm from Toronto, University of Ontario. I was the contractor, installer, and driller. And you may want to make a note that there was no grout. The hydrogeologist decided to not have any grout on.
Really?
And is somebody you know. Anyways, that's the only installation in Canada that does not have any grout.
That
and I did the installation, so I know well.
And the ground loop has survived.
Ground survived, yeah.
Amazing. Well, you're just making my point.
Okay.
Thank you.
So, I'm sorry. I got a couple questions here. The first question is, on a typical deep hole drilling program, how much infrastructure cost per day is installed?
Oh, let me see if I can get my head in that. When you say infrastructure,
So borehole plus grout plus pipe, what's the value of that per day even with a smallest job with a single rig?
oh, as far as the cost per foot?
Total cost per day, yeah, like what?
Well, I can't count that high without more toes.
Okay, well, let's say a range, right?
Yeah. Well, what we're seeing right now in the Rockies, if it's relatively easy drilling conditions to say 500 feet, like in the Denver area, with headering to the mechanic room, $20 to $25 a foot. If we get into, excuse my language, but ugly drilling conditions, which, by the way, we have a lot of trophy homes, 10, 20, 30,000 square foot homes that go in Aspen. They always pick a spot that's on top of a glacial moraine or an alluvial fan that is just nothing but rock. Well, we're up around $60 to $70 a foot now, including headering. And I asked the driller, well, I understand diesel fuel costs have gone up and materials costs have gone up for pipe and grout and all that. He showed me something on a spreadsheet. It's cost him $500 a night to put his crew up in that area. It's a resort town, and even in the summer, there's nothing cheap to put your crew up. So we've actually tried to work with some general contractors. Can you find some lodging for the guys? You might get a better price on your drilling. Everyone thinks about, no, let's just pay the drillers what they want. So, okay.
So the other part of that question is, at what point does it pay off to have an inexpensive third-party quality control person on staff on the site watching it continuously? Because they could also be looking at the amount of bags of grout that go into each borehole, counting that, logging that, watching the ovality, watching everything. So if these people want to build a huge building on an urban site and they want to drill deep, they should be paying for a quality control inspector, period. That shouldn't be the fault of the engineer if they can't make it down to the site and get there and watch 100% of the time.
I don't disagree. And I have suggested it. And they said, no, we'll go with it. But
we need to normalize that.
Well, I want more third-party validation, not just for loop installation, but like what you were saying about controls. And what I'd really like to see is, like on a big commercial project, which a trophy home is a commercial project, is I would like to see functional testing of all the heat pumps. and set a service benchmark for future use. But I'm kind of getting off track on this, but I agree with you. I think the bigger these jobs are and the more expensive they are, people are paying a lot of money and they're expecting a good installation. And in my mind, third-party validation is worth it. But what do I know? So.
Sandra Hawk Drilling, I'm trying to wean down the comments that were questions that I wanted to ask. One, now I'm like, sorry, I drew a blank. When we're talking, everybody keeps going back to don't hire the cheap person, because the cheap person is going to, in the end, make a problem. So your example of the gentleman that wasn't grouting correctly. So first, I would encourage everybody to look for a company that was ICHPA certified. Not all drillers, particularly not in New York, are. So you want to make sure that the driller is certified and that their staff are trained in the correct way to do it. Doing grout is one of those ones that you actually could, as a driller, inappropriately save yourself some money. What is it, like $35 a bag now? You save 10 bags, that's $350 of your own cost that you haven't put in that never gets caught. Some companies unfortunately do that crap. So you're using somebody cheap, you're likely going to be putting yourself into that situation, and if they're not ICHPA certified, then they don't know yet the importance of grouting correctly. And part of that, the comment about the well that was very deep, that wasn't grouted, here in New York, we have some really crap water. We understand as drillers who are actually, our role is protectors of the groundwater. That's what we are tasked with. We are trying to protect the longevity of the well water here. So in doing so, if we're doing a 1,000-foot well or a 500-foot well or whatever, and we're not grouting correctly, we are potentially allowing for salt intrusion in nearby wells. And so I guess my whole overall comment is the cheap person isn't always the good person. And it's been said a couple of times, and yet we still keep using the cheap person. So that would be my plea.
Well, I totally agree, and I appreciate, and by the way, most drillers that are interested in this industry are attending conferences like this. So I'm not worried about the guys and gals that are here. I'm worried about the fly-by-nights that never get involved in the industry. Okay, we got some more questions. Yes, sir. Well, we got hands here and hands here and hands there. I think
we got about 7 minutes left before lunch, but we can stay as late as Terry wants.
I can stay as late as, I don't need any more food. I've got plenty of ballast.
A question and I guess a couple of comments. As far as where can we go to find information, you mentioned some ASHRAE information, I believe.
Yes, sir.
Regarding 1.5 inch versus 1.25 inch loops and so on. I'm finding a lot of designs out there that they're putting 1.5 inch loops in fairly shallow applications, 450 feet and 500 feet. And how can I go back to the engineer and say, gee, maybe we ought to reconsider this? You've got not only the cost factor, but is it more efficient to put an 1.5 inch loop that's got 30% more fluid in it than an 1.25 inch loop? And are you getting the proper thermal exchange out of that, potentially?
Well, a couple comments. I agree with you. It's good to know why. Well, one of the questions can be answered. Maybe it's like pumping power. So if you got a big field, like we've got, I'll give you a really good example. We've got a project at the U.S. Air Force Academy. It's not as big as some of the things I've been hearing about, but it's not a small job. 180 holes, 600 foot deep. We initially went with 1.25 inch. We found we could drop the pumping horsepower by going to 1.5 inch by like 20%. Now, on a smaller job, that wouldn't make that much difference. But one thing to also understand is the greater volume of fluids you have, the more heat or more energy carrying capacity of that volume of water. So that's not a bad thing. Is it worth the extra cost for the 1.5 inch pipe? I don't know. That's a judgment call on every job. But here's another thing. With bigger pipe, you're not changing the thermal conductivity of the geology,
right,
but you're lowering the borehole resistance because now you have more exposed pipe in the hole on the outside diameter of the pipe. So is it valid for every job? I don't know. It's a judgment call on every project. But those are the questions you need to ask the engineer or whoever designed it.
And the comment I only had was sometimes on a commercial project, the cheap guy gets the job because the general contractor is, or developer, they're going cheap.
Well,
and they don't care about if you're IGSFR certified or whatever. They just want the
you're
cheap
right.
price.
Now, what I've been doing because of that, because it's my liability, and I'm not a licensed PE, but I'm working under licensed PEs, but I still have to have liability and errors and emissions insurance, which I do. But I put it in my spec that I want to review every response to the RFP from all the drillers. So I can look for what I call NICUs. You know, there are some, we don't have them so much anymore, but what I call artists. They change order artists. They come in real cheap and then they change order the job. Again, the people that attend these conferences, not so much worried about. I'm worried about the fly-by-nighters. But what I've done on several jobs is I've caught some things that, oh, this guy's really cheap. Well, yeah, well, there's a reason why. And we need to ask that contractor, has he accounted for this, accounted for that? Because we're not going to accept change orders for this or that. And guess what? Some of these guys have said, no, I declined to bid. So, okay, that's good. We're both better off. So, and I'm not trying to be a hard guy. I just don't want drama to deal with myself or the client to get a bad job. Yes, ma'am.
Hi, Elizabeth McCorvey. Two things. In terms of the drillers, I'm like this lady. Is there a list? Has anybody had any problems with the National Groundwater Drilling Exam? Because I've taken it quite a number of times and it's just so difficult to pass. So it makes it very hard for us. I just wanted to take and pass the exam so that I could tap into the benefits to pay a driller. But does anybody have a list of drillers that have passed that exam so that because it's not fair if somebody out in Indiana can control and nobody in New York can get any of the desired benefits. Everybody says, we all know that the drilling is the most expensive part of the job, but if we can't tap into any of the incentives for our state, it's not fair.
Well, I've got a couple of responses to that. If you're referring to National Groundwater Association, they should have a membership list online. The second thing is, you've got all kinds of experience here locally for New York that I'm sure, like the young lady that just said, she probably doesn't want to name her competitors, but she knows who they are. And she probably knows the good, the bad, and the ugly. So I would network with this group. I know in Colorado, people ask me, who can we call for driller? I've got a list that I will send a general contractor or client. These are the guys that I know and trust. And I just wish it was a longer list. We really don't have a lot of assets, and we're blowing up in the Rocky Mountains right now from Montana to New Mexico. And we need, by the way, any of you guys drillers want to travel west? We've got some work for you. Is that?
Yeah, just, if there was some kind of advocacy for New York.
Sure.
For people could get, because I'm a not-for-profit. I'm not interested in having a drilling rig. I just want to be able to help create and get our fair share of some of that desired money. Not right.
I believe NY-GEO has a list of member drillers, do they not?
Thanks a lot. Good presentation. A few questions. Regarding the grout control, from my recent experience in this industry, from what I saw, it's kind of hit or miss. It's almost impossible to control how the grout is mixed, and it has a critical importance in terms of thermal resistance. So some of the key grout providers, they actually give you free sampling so you can basically sample as you go during the job. At least we do. Every job we do, we take at least 3 samples from each well. We send it basically to the guys, and they reply to us with the mud weight and actual thermal conductivity. So you have a quality check on each well, what grout and what basically you achieve. And it's basically straight away checking how is your contractor doing.
Well, as a matter of fact, on our spec, we want, if it's, no matter how many rigs are drilling holes on our projects, if it's just one rig, we want 1 grout test per week, random. If our thermally enhanced grout results are coming in low, we address it, before the job's done, hopefully. And I've had some drillers, they'll take the sample, no one was bugging them, and that jar is rolling around their truck for a week and a half, and the job's almost done. I said, send it in now, guys. It's not costing you anything. So I agree with it. By the way, drillers get a bum rap for their cost of a ground loop. Well, they can justify their costs. Got a reality check test. This is kind of off point. So if it's a 100,000 square foot building, divide 100,000 square foot into the total cost for the drilling. Now, take the controls cost and do that same thing. What you're going to find is the controls cost it's not unusual for it to exceed the cost of the drilling. Now, how can that be? Because they don't have the materials that are burning or anything like that. And most ground source heat pump systems have fewer control points than a conventional mechanical system. So why do we have such high controls cost? Well, that's a good question to actually pick on the controls guys first before you pick on the driller. Because a lot of times they can't justify it. They're just used to getting their way. So just a comment. Yes, sir.
The second point is regarding the quality, basically the issues with the long 800-foot wells plus. So we actually do 800-foot wells with quad loops, 1.5 inch. And initially when we grout them, we were putting the caps on top. And what we noticed after the job, when you remove the caps, these caps shoot at least 20 to 30 meters because so much pressure is trapped inside the loops because of basically this pressure of collapsing. So as a way forward, we're now installing the special basically caps, and we pressurize the loops prior to the job. And this is the way how you can address the quality issues. So because I don't know if there's anybody from HDPE loop provider here who can basically provide the spec in terms of HDPE loop quality, which you're sending to the site, because I'm sure it's more than 1%, and it's probably 3 to 4%.
Well, it's interesting you say that. I actually suspect you've got some pipe ovality, and that's why it's compressing. Because I've actually done 600, 700-foot ground loops, go out and cut the tops off, and you would expect if that pipe's compressing, that water would shoot up. Never had it happen.
While it's the grout is setting, so basically when the grout is set, then basically you kind of equalizing the pressure, and then you kind of fine. But during the grout liquid state, this is kind of issue. And I mean, you applying how much? You applying almost 180 psi. This pressure along the whole wellbore length definitely will compress it.
All I can say is I've never experienced that, and I intentionally have cut the tops off, and we've never had that issue. Now, I'm not saying I know the answers, but I suspect that pipe was oval to begin with when it went down the hole, to your comment. And, because if it's already pre-weakened, that pressure is going to be able to work on that water.
I mean, while you're running the HDPE pipe is soft, correct? So claiming, I mean, for the oil and gas industry, we can claim a quality of 1 to 2%. Claiming the quality of 1 to 2% for HDPE pipe, I think is not reasonable because of the material you're using. Anyway, the whole point is just basically we use the pressure to compensate for the collapse.
Sure. Thank you, guys. I appreciate it. Don't be afraid to go deeper.